Hello, my name is Gerhard Adam, and in this module we will continue exploring the mainframe environment. Specifically, we will discuss the very common file organization referred to as partitioned datasets, or libraries. With partitioned datasets, there are two access methods employed. The sequential access method is how individual members are processed, while the partitioned access method, or BPAM, is used to manage the directory entries. A partitioned dataset consists of a directory located at the beginning of the file, which points to all of the individual members in the dataset. Each member is a sequential file. This type of organization is also referred to as a library. The way it is used allows the addition of individual members within the dataset, with each member having a directory entry associated with it so that it can be located. As a result, we can loosely compare this to the idea of a directory under Windows, where each entry represents a file within the directory. The benefit of this type of data set is that it allows us to keep all manner of files, just as we might do on a PC, without having to have a unique data set defined for each one, especially since many of them may be quite small. As a result, we can have a single partition data set that could have hundreds of members in it. As we saw with our sequential file, when we create such a data set, we specify the logical record length as well as the block size. Once this is completed, members can be added without restriction as long as they also have the same record length. There are no restrictions on what the member itself contains, so it might be a program source code, it might be a basic text type file, or JCL to run work. Since the point of libraries, or PDSs, is to avoid having hundreds of small sequential data sets, then we will find them used whenever there is a large collection of specific types of data that benefit from being kept together. One particular use is also for executable programs, so that these libraries are available for ZOS to search, so that when we wish to run a program, the library directory entries can be readily searched to locate the program we wish to execute. To help clarify this concept, let's look at a comparable mechanism in Windows. If we examine a Windows directory, we can see that there is a directory or folder called Biology Books, with a bunch of files in it. The specific files can be seen in the right-hand window. If we applied the same terminology to this comparison, the folder, Biology Books, would be the equivalent of our dataset name in ZOS, while the individual files would be the equivalent of the members in a PDS. Let's now look at an example of a partitioned data set so we can see the similarities. In this display, we can see a list of data sets that are all under the TSO user ID of GATOM2. From this list, we wish to examine the contents of a data set called gatom2.jcl.cntl, which is a partitioned data set. When we select this PDS, we can now see the member list of all the files that are stored in that data set. So, to consider the similarities to the Windows example, instead of selecting a folder to view, we selected a data set. When we look at the data set, we can see the individual members listed, just as we saw the files listed under the folder entry. It's important to remember that the comparison being made is simply to show some of the similarities between the two different systems, and is not a suggestion that they are the same thing. Windows uses this basic hierarchical file structure for all its data, whereas in ZOS this is only applicable to partitioned data sets. In ZOS, everything is defined as a data set, but the internal organization of that data set is subject to how it was initially defined.